An excavation plan is outlined in the figure below. Each grid square is 50 by 50 feet. The numbers are depth of cut in feet at indicated locations. The total volume of cut in yards cubed is most nearly. All right, so let's solve the surveying problem here. We have A, B, C, D, this polygon here, and in every corner we're shown the depth of cut. So at A we have 3.4, B 2.4, C 0.9, and D 1.6. I'm gonna ask you to try and envision this shape here. In order to calculate the volume, we're gonna need the area of ABCD, right? Multiplied by the height. And the height is going to be an average of all of these. So one thing I can think of is we can calculate the area using the method by coordinates, or the area by coordinates. I actually have discussed this in one of my previous videos, and if you go to the FE handbook, I have it right here, but if you're anywhere in the FE handbook, you just type area by, there you go, it's here. But anyway, if you just are anywhere and you say area by coordinates, there you go, it gets you here, and the formula is right here. And if you don't know how you do this, I'm going to quickly just draw this polygon or traverse, close traverse, A, B, C, D, E, and you can have, E, F, G. I'm going to go with A, B, C, D, E. And the way you do this, let's go ahead and follow this pattern here in the problem. So we take X, or let's say we start in point A. And of course, this point A has coordinates XA, YA. Point B has the coordinates XB, YB. XC, YC, XD, YD. And let's just go ahead, I guess, do this as well, X and YE. And if we are following this pattern here, so the way it's done is XA, so you start in point A, you take X of point A, multiply by the Y, so you move forward, right? Multiply by the Y of point B minus Y of point E. So you take Y of the forward point minus Y of the backward point. That's how I think about it. And if you move to point B, the same thing, you take X of point B multiplied by Y of point C minus Y of point A, right? Moving forward, point C over here. It's going to be XC multiplied by Y of point D minus Y of point B. So this is a pattern, and if you get to understand and recognize how this formula is completed, this is pretty easy to apply. So now this is one way you can solve this area using area by coordinates. This is because we have this grid here, and we know in the problem we are told that each square is 50 by 50, so we can easily determine the coordinates of each point here if we were to consider this Y and this X-axis. Then the point A is going to have 0 in X direction and 1, 2, 3.4, 5, 6 squares times 50. I'm going to have 300 into the Y direction. And you can do this at every single corner or every single point, and you can use the formula of area by coordinates. Now, another way you can do this, if I draw or I connect this line, these 2 points B and D, I get 2 triangles. We know the area of a triangle is equal to 1/2 multiplied by B multiplied by H, right? So in this case, this distance over here, it's going to be 6 squares multiplied by 50. So this is 300. And here, we're going to have 4 squares multiplied by 50. This is 200. And this distance over here, it's 3 squares. Let me see how I can show this. And this is 150. So let's go ahead and calculate this. So the area of first triangle A, B, D is equal to 1 over 2 multiplied by B, which is 150, multiplied by H, which is 300. So let's see, we can, this is 150. So it becomes 150 times, and I get an area of 22,500 feet squared. Now that we have the area, let's go ahead and calculate the volume of this triangle. So the volume of ABD, it's going to be equal to the area of triangle ABD multiplied by the age. I'm going to add age 1 equals. Now, age 1 is going to be the average depth of all of these points. And how do we calculate the average? The average is going to be just adding them all up. 3.4 plus 2.4 plus 1.6 divided by 3. 3.4, 2.4 plus 1.6 plus 3 divided, and I get an depth or height of 2.47 feet. And now I can go back in the volume formula and I can substitute. So I have 22,500 multiplied by 2.47. And I get a volume of 55,500. And these are feet cubed. Okay, so we're done with the first triangle. Let's go ahead and calculate the area of our second triangle, which is BCD. Again, we're going to have 1 over 2 multiplied by B, which is 200, multiplied by age, which is 300. And this is going to give me an area equals to 30,000 feet squared. And again, let's go ahead and calculate. This is H1. I'm going to calculate right away H2, which is the depth, the average depth of this second triangle. Well, not triangle. This is actually a triangular prism, an irregular triangular prism. So H2, let's go ahead and add them up. 2.4 plus 0.9 plus 1.6 divided by 3, and 2.4, 0.9 plus 1.6 plus 3 divided, and I get an average height of 1.63 feet. And now we can go ahead and calculate the volume of triangle BCD. And it's going to be equal to the area, which is 30,000 multiplied by 163. And I am getting a volume of 48,999.99. So I guess this is approximately 49,000. And these are feet cubed. And for the total volume now, what we're going to do is we're going to go ahead and add volume of triangle ABD plus volume of triangle BCD. And this is equal to 55,500 plus 49,000. And this gets me, so 49,000 plus 55,500, 104,500, and these are feet cubed. So the total volume of this shape here is 104,500 feet cubed. The problem is asking us to calculate this in yards cubed. Okay, now the FE handbook doesn't really give you a direct conversion of feet into yards. If you go to units, the only thing you have here available that is going to help you is this. You have meter in order to transform or to convert meters into feet. And then you have meters into yard. So if you need feet into yard, you have to go through this, convert first into meters and then those meters into yards. But if you are able to memorize, it's very helpful to memorize that 1 yard equals to 3 feet. If you're able to memorize this, that's great. If not, you can use the handbook and convert feet into meters and then meters into yards. So let's see, we have 104,500 feet cubed, and we would like to convert into yards cubed. So I know that 1 yard cubed is going to equal to 3 feet cubed, right? Or I can rewrite this as, let me delete this. I can rewrite this as 3 cubed as 3 cubed feet cubed. 3 times 3 times 3, which is 27 feet cubed. All right, so now we can get rid of feet cubed. This is yard cubed. Okay, so the only thing now we got to do is just take 104,500 divided by 27, and this will give us 3,807 0.4 yards cubed. And the closest answer is, this was supposed to be 39. Okay, so the correct answer is C. Another problem here. Earthwork estimates for a highway project are summarized in the following table of end areas at stations 100 feet apart. The total earthwork volume in yards cubed between stations 20 and 24 is most nearly. Okay, so this is actually an easy problem if you understand what is happening. And I'm going to explain it to you. We're going to use, let me go back to FE handbook. And I will go back to this page here. And I'm going to use average end area formula, which means that the volume is equal to A1 plus A2 over 2 multiplied by L. Just to visualize this, imagine you have this area here, and this is at station 20 plus 0, 0. And then you have another area at station 221 plus 0, 0. And you have the distance between them is L equals to 100 feet. In order to calculate this volume between these two stations, you use this formula. So this is what we're going to do today. Let me first delete this. So I need this space. I would like to use this table in order to make this easier. So what I'm going to do, I will try and continue this because this is going to make it easier on me. So I'm going to put distance L because sometimes it's possible that you're going to be given a problem where the distance between stations, it's not the same, so you need this. Okay, so distance from station 1 to station 100 and then 100. We have 100 feet apart stations. Okay, and this, we're going to have volume in feet cubed. And the way we're going to calculate the volume, we're going to use this formula here. And this is going to be, so let's say V1, we're going to do 405 plus 576 divided by 2 multiplied by 100. Okay, let's go ahead and do that. 405, 576 plus 2 divided 100 multiply. So we are getting a volume of 49,050. Now, volume 2 is going to be equal 576 plus 432 divided by 2 and multiplying by the distance between them, which is 100 again. Okay, let's see what we get here. 576, 432 plus 2 divided 100 multiply. I'm getting an area or volume, excuse me, of 50,400. Okay, moving forward, I'll do V3 is going to be equal to 432 plus, so I get this, plus this guy, 378 divided by 2 and multiplied by 100. Let's see, we have 432 plus 378 plus 2 divided 100 multiplied. So we get a volume of 40,500 feet cubed. And the last volume here equals to 378 plus 630 divided by 2 multiplied by 100. Let's see what we get here. 378, 630 plus 2 divided 100 multiplied. So I'm getting a volume of 50,400 feet cubed. And now we're going to add them all together and sum them up to get the total volume. So 5,400, 4,500 plus 5,400 plus 49,050 plus. So I get a total volume of 190,350, and these are feet cubed. Again, look here in the problem, we are asked to calculate in yards cubed. As in the previous problem, we know that 1 yard is equal to 3 feet. So now knowing this, we can go ahead and convert. So we're going to have 1 yard cubed equals to 3 feet cubed. And this means feet cubed and feet cubed are going to go away. 3 cubed is 27, so I have to divide my number to 27 and I get 7,050 yards cubed. And the closest is B. The correct answer is B.